My name is Suri. This is Noel here. We are both part of the Java platform team. I'm a group product manager. I'm responsible for the embedded portfolio of products, and Noel's an architect in Java Embedded. Before we get started, I would just like to get a quick show of hands. How many of you are embedded developers? Okay. And the rest of you just curious about the embedded space, what's going on, which is great. Very good. And I'm assuming the rest of you are just enterprise developers working in Java, servlets, Java IDE, all that kind of good stuff. All right, very good. So this talk is about a product called Java Embedded Suite. And Embedded Suite is really about bringing middleware technologies that are popular on the server down to embedded devices. And that's what the whole talk is about. We'll go through some introductions in terms of what is this technology, where does it fit in the big embedded space, and then Noel will show a demo of how do you actually develop applications, and you'll find a lot of commonalities in terms of how you develop applications for the server with how do you develop applications on embedded devices. All right, so getting started, I need to show you this. It's a disclaimer which basically says you can't make any commercial decisions based on information provided over here. Agenda. So we'll start with the Internet of Things because that's the overarching theme here on why we even care about this product in the first place. The embedded ecosystem today, on where we are today in terms of embedded application development, and what benefit do we bring. Then IoT with Java. And then go into a deep dive into Java Embedded Suite, the features, what are the different components, and then walk through a demo of a really code walkthrough of how do you actually develop an application using JES. And when I say JES, I basically mean Java Embedded Suite. IoT is Internet of Things. All right, so Internet of Things is here. If you haven't heard that before from the rest of the keynotes and the other sessions, this is something you're going to keep hearing throughout the sessions. But basically, there'll be 50 billion plus devices out there by 2020. That's the minimum number we've seen, so we go with that. We actually heard anywhere from 50 to 200 billion devices that will be out there generating data. And all of these devices, there's immense amount of diversity in the type of devices that exist out there that are creating data. And the end result of it is all of them are generating data. And we need a standard way of acquiring all this data, managing it, integrating it with backend systems, analyzing it both on the server as well as locally. And one of the key things that Java brings to IoT is local intelligence. So being able to take that data and analyze it at the source so that you can take more real-time decisions. If there is a boiler which is about to explode, I don't want that data to go to the server and then get processed there and then send back a command saying turn off the pressure valve. That needs to happen right away, right there. So that's the kind of stuff we're trying to bring in. Local intelligence where network may be disconnected most of the time. I may be working on a satellite network and I may not have network connectivity all the time, but I still want the sophisticated functionality. How do I do that? And that's something what we are trying to talk about today. Today, 11% of data is machine generated. In fact, most of the data that exists today in the enterprise databases, corporate databases, is somewhere, somehow entered by a human. But very, very little percent of it is machine generated data, which is generated directly by a machine and sent to a database. That is definitely changing as you will have 20 billion, 50 billion devices out there. A large amount of data is going to be generated directly by devices and sent over to a database. And then it has to be refined along the way. It has to be processed along the way. And that is where JES is going to fit in. So what are the challenges in this? The first thing, acquiring the data from all of these devices. So how do you acquire data in the first place from a sensor which may be connected over a whole bunch of different networks? So if you've been listening to other IoT talks, or as you'll go through other IoT talks, one of the key things that you'll keep hearing about is the different types of networks that exist out there. There are short-range networks like Bluetooth, there's short-range networks like Zigbee and Z-Wave, or you have a wired connection like a USB or serial RH232 connection. How do you connect to these devices in an abstracted way, the way we are used to doing it in Java, where all you do is just say, use java.io or use NIO and just create a connection. And then, voila, you have a connection, a server socket. How do you do that in a world where every device is talking a different protocol? And that's one of the bigger challenges that we have to solve from an application development platform point of view. How do you provide that common interface? How do you manage that petabytes of data in a scalable architecture? Gathering all this data and then actually being able to derive some context around it. Like, I have data sitting there, but how do I map it to a person from which that data came? Or maybe it came from a medical device that a patient X was using. How do I map that data when I have petabytes of data stored in my architecture somewhere? So we need a way where you have identity of data as it goes through the network all the way to the data center, and then be able to map it back and forth. And how do you leverage existing enterprise architectures? So some of the solutions are, of course, challenge of acquiring data from millions of devices, decouple software development from hardware development. Today, most of embedded development happens where you write very embedded device-specific applications. You actually go in and say, my device is going to have 4 peripherals, and I'm going to write to those peripherals. And yes, it works, but it's not scalable. It's very difficult to make a device that's completely dynamic, where you just plug in any device of your choice and then expect the application to just work. That's the kind of problem that we need to solve, and one of the ways to do it is to decouple software development from hardware development. Integrate databases, data management, and data analysis tools with IoT networks, where build that identity infrastructure that can map devices to data. And that's one of the key things that I spoke about. And then leveraging existing enterprise technologies, such as web infrastructure, security infrastructure, and so on. There are technologies out there today with IoT which are trying to build parallel networks or parallel data centers. What we want to promote as part of the Java ecosystem is leveraging what we've already built as part of the enterprise Java technology to fit into IoT space, so that you can leverage all your existing knowledge, you can leverage all your existing investments in data centers for IoT. So where is the embedded ecosystem today? This is an interesting challenge that we are at this point. We're at a crossroads where we see the opportunity that IoT can bring. IoT is opening up because communication has become cheaper. Moore's law has caught up to an extent where you can now run an app server on a $35 device, actually even smaller devices. This was never possible. You needed a $2,000 server at least to run a proper app server. You can run an app server on a $35 device. If you look at the ARM roadmap, they're putting in 64-bit processing on like really, really small chips. 32-bit processing is just completely common now on ARM microcontrollers. So highly diverse and changing use cases and technologies today. There's so many technologies that are evolving at this point that can leverage IoT. If you look at the Tesla car, I mean, that's an amazing example of how you can take something and just put in a whole bunch of technology and then make a device that is completely out of the world in a way that it's really changing the shift. There's a shift in paradigm in terms of how you use a car. And that's the trend that we're going to see moving forward, not just in cars, but across all devices. The Nest thermostat, if you've seen that one before. I mean, thermostats were just these little things with up and down arrows. Nest just completely changed that. So those are the kind of use cases that are emerging, and which is now possible, which wasn't possible before, mostly because it was much more expensive to do it. People didn't want to pay $1,000 for a thermostat, but now you can build the same thermostat in like $200, and that's now approachable. Hardware capabilities and connectivity evolving. Value is in software. If you were here last year for Java 1, actually the SVP from Freescale, he had a pretty good comment. He said, The difference between a washing machine of today and a washing machine 3 years from now will be 10,000 lines of code, which is actually very relevant because there's only so much you can do now in terms of how you do your wash cycles and how you rotate your drum. It's really on building in that intelligence into the washing machine. That's where the evolution is going to come in. And we see that across all kinds of appliances, all kinds of devices. And that's where the value is. But embedded software development today is extremely difficult. It's C, C++ based. Of course, there is a lot of expertise, but the barrier of entry into that is very high. And it's very proprietary. If you're using specific technologies, you have to stick to their SDKs, and it's the code that you write is not always portable. It takes effort. If you have devices, if you're an OEM with a catalog of 100 devices, you probably have 20 different development teams out there creating applications for each of these, for all these 100 devices. And it's not uncommon for a big OEM to have that kind of catalog. It's expensive to reinvent and reintegrate must-have features. So you've shipped devices, all of a sudden security has become a big scare, or every other customer is saying, I need management of my devices. How do you do that? It's very expensive to go back and reflash your devices, bring in those kind of features. Then finally, value of data is gaining importance as a business driver. If you're not already gathering enough data from your device, it's very difficult to go back and change everything to do that. And time to market, of course. No need to emphasize on that point. So this is where we are today. And some of the common pain points we hear when we talk to customers. And Java Embedded, by the way, has been used in devices for a long time. Right? We have many examples. Like one of the more common consumer example is the Amazon Kindle, which is based on the e-ink, which uses Java SE Embedded. Actually, a version of Java SE Embedded. So we have a bunch of consumer devices out there, many industrial devices out there that use Java Embedded. So we have a good kind of base to go talk to understand what are the common pain points. Some of the common things we hear is, how do I tell my boss that we can't find good developers? It's so difficult to ramp up a team of embedded developers today, which to fit your needs, that's become a very common pain point that we hear. BOM costs, the bill of materials cost, is one of the key considerations, of course. You don't want to spend too much money. You already spend enough on your hardware. Software always becomes the key problem when you're trying to put in more. So that's one of the key areas where people are worried. New devices need to be deployed in 30 days. Well, that might be a little extreme, but it's not that uncommon. It's so competitive now that you have to be very, very nimble in terms of getting devices out. What if this vendor locks us in for years to come? In embedded, it's still proprietary technologies. So if you're writing to a particular embedded hardware for a certain vertical segment, you may be locked into the vendor technologies unless you have a way to abstract out things. So that's one of the key problems. Who will support these solutions 10 years from now? There are smaller companies out there that can build things for you, but will they be around? Will the technology choice that you're making today, will that be around 10 years from now? And finally, how do you replace things once the device has shipped? How do you add functionality once the device has shipped? So these are the common pain points we keep hearing. So our strategy for this is, of course, Internet of Things with Java. And one of the things we keep pointing out is it's not Internet of Java things. It's Internet of Things with Java. So we believe that Java can bring in a lot of benefit, not just work with devices that run Java. Of course, if you're running Java on the device, we can definitely do a lot more. And most of this talk is going to be focused around putting Java on the device and what you can do. But our strategy is to allow you to leverage Java across the stack, and even if you're not using Java on the device, but still be able to leverage benefits from it. What Java can do for you is basically, if you have Java from device all the way to the backend, it can provide, the key things that can provide is, first thing, it can provide a common security model. One of the key things that's missing today in the embedded world is a common security model between the device and the backend. On the backend, we have evolved the security model, especially with enterprise Java. It's fairly well evolved now. You have of course, the whole container models that have evolved. You have the IDM, identity security model, that is fairly evolved now, integrated into the Java EE container, which is all very good. Of course, it's not perfect, but it's way more sophisticated than what exists today on the devices. And we need to bring that common security model onto the devices. Development, today, your embedded team is, of course, always different from your backend team. They probably never talk to each other, except for deciding some interfaces. They're completely different skills at this point. But it doesn't have to be that way. What we're trying to do with Java, of course, is if you were at the keynote yesterday, one of the key messages that we tried to emphasize was there's no longer a Java embedded, Java ME developer, a Java SE developer. There's a Java developer moving forward. We want to allow Java ME developers to leverage the skills to build enterprise apps and vice versa. Get the enterprise developers to start building embedded applications. There's no reason for them to think that all that is out of reach for us, that's out of scope. If there is opportunity there, you need to be where the opportunity is, and we will help Java developers to move downstream for that. And a common management model. Java can provide you that management framework where you can easily deploy Java applications across the board. And one of the key things why, again, Java is important on devices, it's to some extent the way I look at it is the whole thick client, thin client stuff that happened on the web, where we first were very thick with desktop applications, and then we went to the extreme, we went thin, and then we realized, no, that's not good enough either, let's go back to thick. And now we have somewhere hybrid, where we seem to have now settled on thick. So it's the same thing in a way. Today, there were first embedded devices that were thick in the sense that they did everything themselves. They didn't really talk to anything in the back end. Now the push is more towards, let's just take all this data and then move them to the cloud, and that'll be it. Well, once we have the data in the cloud, we can do everything. But that's a very thin model. Again, you're not doing much on the device. All the device is doing is just gathering data and sending it over. What we need is something in the middle where the device is able to do more. The device is able to make decisions itself. But at the same time, be able to send data to the cloud so that you can do much more deeper analysis that you would need that you can't do on the device because you may need other data sources as well. So that's the model we're trying to go to, where Java enables the device to be intelligent, scalable, and supportable or manageable. So that's our vision. We're trying to create an open, standards-based, secure IoT platform that can easily integrate devices with enterprise applications while enabling simple management, application development, deployment, and scalability. We'll be focusing on this part today. This is kind of like our conceptual architecture. If you are here by any chance for our session earlier in the morning, we talked much more in detail about this. I'm not going to spend much more time today on this one. But this is kind of our vision for how a IoT architecture might look like. You would have devices talking over cellular networks to data centers, but then there are many devices which won't be able to talk directly to data centers because they are running on short-range networks or are battery-powered. So those devices would typically talk using a gateway. And then on this side, you would have a communication gateway which is securing all the communication that's coming in and also doing protocol translation, because all these guys out there could be talking many different protocols. Like if you're on a satellite, Iridium, you're talking SMTP, or basically you're talking email. If you're on an Ethernet or a Wi-Fi, you're talking HTTP or TCP/IP. There are other standards emerging such as 6LoWPAN and CoAP, and there's MQTT. There's a whole bunch of these things that are evolving, and we have no idea which is going to succeed at this point because this is such an emerging industry. So this component is going to be key in kind of abstracting out that part where it will be able to work with different technologies out there. And then we'll leverage our existing enterprise technologies such as access management, identity, data routing technologies such as coherence or caching technologies or event processing technologies to move data to the backend systems, SOA and everything else. So that's the conceptual architecture. Today we're going to focus on that part. this box, which and applications of that gateway range in pretty much every industry. In home automation, it's fairly common to have a gateway device that sits and connects to all the appliances in your house, your refrigerator, your HVAC, security system, etc. In the medical field, you would have a patient bedside monitoring device, or in a home, a remote patient monitoring device, which would be connected to the blood pressure monitor or to the pulse oximeter or something else, gathering data. In industrial automation, you would have it at a CNC machine might have a gateway with a whole bunch of sensors that it's connected to. So a gateway is a pretty crucial component in many devices, and it's also a great component there because it tends to be stationary. It tends to be higher powered than most other devices. Many times it's always on and always powered on, which allows us to do more on this device. So it's kind of like a mini server sitting remote, but then it has its own characteristics in terms of it needs manageability, it needs a lot more features. So moving forward then, Java Embedded Suite, which is a product from our Java Embedded portfolio, is targeted towards gateways. What it does, it provides enterprise middleware capabilities on embedded devices. Basically, you can use your enterprise knowledge of writing servlets, of creating web applications, creating REST web services, to write applications on a gateway. We want to standardize on REST for all our communications. We feel REST has matured to an extent where we have enough infrastructure that understands REST and knows how to secure REST communication. So we want to bring in those capabilities on embedded devices. And there's enough libraries out there, there's enough reusability that you can do with these technologies. But what we've done, we know that you can't just take a Tomcat and just run it on a little Raspberry Pi. You could potentially, but you'll have performance issues. Definitely not WebLogic. So we've taken Glassfish, which shrunk it down. We've reduced the overall footprint versus competing platforms or DIY solutions. So you can take things together, kind of put them all together, and have a stack running. What we do at Jess is we kind of optimize it all together so that we remove a lot of extra components that you may not need, just to make sure that it is in a compact footprint. We enable configuration options to do deployment-specific tuning and performance. And we have tested binaries for ARM platforms, for x86 platforms that you can just deploy on developer boards like Raspberry Pi or BeagleBones or anything else. We'll show you one running on Raspberry Pi today. And you can reuse the existing knowledge in Java and Java EE. So here's what we have today. It's called the Java Embedded Suite 7. It was our first attempt at bringing enterprise middleware onto very small footprint devices. What we basically did was we took our Glassfish web server, our app server basically, and shrunk it down. We removed a whole bunch of things, like the JSP container. We removed that. We removed EJB support and really brought the web profile of Glassfish and put it on Java IC embedded. We also took Java DB and combined it all together. So now you have a mini enterprise-grade server running on a very small footprint device. And so you could just write a web application and just deploy it, and you could get running. There was a really great example of two developers from Brazil who took this and who had never done any embedded development before. But they came up with this interesting idea and came up with a prototype in just a week where they had a robot running on Arduino. And was it the robot used to dance, right?
It was a Raspberry Pi with an Arduino.
It was a Raspberry Pi with an Arduino, and they put Jess on it. And then they had a guitar, and somehow they connected the guitar over wireless to the Raspberry Pi, and they would play notes on the guitar, and based on those notes, the robot would dance. And they did the whole application in 2 weeks or something like that. And the fact that they could write an application that could just do REST all the way through was what made the development cycle really, really small, and they could just change things on the fly. So that's the power that really simplifying application development does. that you don't have that barrier anymore on how do I don't even know where to get started kind of thing. But moving forward, we definitely are changing this model, and that's something we want to talk about today. The first attempt was much more basic. We just started off, we said, let's first enable web applications, but now we're aiming higher. We're going to go get remote management into it. We want dynamic lifecycle management of applications on the gateway. We want to do far more services. We want to do core services that are started as part of the gateway itself that your applications can leverage. So that's the model we're going to do moving forward. We will have, of course, Java IC embedded. We'll put a management framework that will allow you to do remote management. You can remotely deploy applications, install them, uninstall them. You can stop applications as they're running, pause them, restart them. So all that stuff will be built into the framework. All of it will be done based on OSGi. And OSGi is a fairly accepted framework for embedded, and Noel will cover a little more about it. We will have Java IDEs, so we'll have SQL database running on the device, so you can do local storage. So which way, if you have cases where there's intermittent network connectivity, so you can keep caching data locally. And then when you have the network established again, you sync it. And we also have another NoSQL database over there option, which is Berkeley DB. So you can also put a NoSQL database if you are focusing more on key value data, then just use NoSQL Berkeley DB over there. JAX-RS is a Java standard for developing web applications, REST applications, and very easily. And JAX-RS allows you to just host REST web services on the servlet container over here. So in a way, your device is a resource at that point. Your device is nothing but you can just go in and say, just imagine a model where you're discovering a device and you discover services on it, and then you can say, what can I do with this device? You just call the REST web services, and you can just do whatever based on discovery at that point. You just discover the services, you say, what services does your device expose? Well, I give you temperature data here. Let me just call the method that gives me temperature data. So the dynamic nature that REST can bring to this, and then again, everything can happen securely at that point. Use SSL, use your standard digital encryption technologies. Or you can just write a simple web interface, run it on the servlet container. So that's the model we're going to do moving forward. It's all based on OSGi bundles. So before I hand over to Noel for a demo, I hope I'm good on time. Oh, exceeded a little. Here's the high-level features at a glance. Bringing enterprise middleware capabilities on embedded devices. An integrated Java application server for development and deployment of applications. A good high-performance Java DB. Java DB is based on Jersey, Apache, not Jersey, Derby, from the Apache project, and it's used very widely, and we're just bringing it onto embedded devices. You have RESTful web services development and deployment. You have pre-integrated binaries ready for production. OSGi, which is not there yet, but something we're working on, will bring in that managed application container, which will also bring in remote management. And finally, we're optimizing it all for ARM and other embedded platforms. So I'll let Noel talk a little more about the technical details.
Thank you, Jay. So let's, I don't know whether all of you are already familiar with OSGi, but I'm sure that some of you are at least. So the OSGi Alliance was set up 14, 15 years ago now, and was originally focused on home gateways and so on. And it's found its way into all kinds of places, including enterprise Java as well, of course. So dynamic module system, it's been through multiple iterations and some changes, slight changes of direction, but essentially it provides a service-oriented, componentized environment for developers, and it provides a standardized software lifecycle, provides security, and it provides a way in which you can dynamically manage the functionality of the device. So you can update services, add new stuff that wasn't there, do all that without having to go through the highly risky process of reflashing the device. And so this is kind of an important building block for being able to manage devices that are going to be sitting in places that are often inaccessible. Maybe it's someplace inside a machine on your production line that you're not going to stop the production line to be able to go to that device with a USB stick to upgrade the software on it. So you have to be able to do all this stuff dynamically for this all to work. So it's been very widely deployed. It's actually specified by some of the specifications, such as the Home Gateway Initiative. Oops. Next.
There you go.
Thank you. Specifically embedded, and I'm going to leave aside the enterprise use of Java of OSGi for now. It's being used in a lot of embedded spaces, and it's very well accepted there. And it gives you the basis of being able to do remote management of the software lifecycle, both the platform and services and applications on the device. So you have a life cycle that allows you to install, start, stop, update, uninstall, and so on. And the model allows you to share resources and services in the device, and that allows you to actually start building applications that can be aware of the resources that are around on the device and actually respond to things as they change. And it provides a nice environment for reusing functionality and being able to implement the same functionality in multiple different ways where you need to do that. And it's also, it's 100% Java technology, so it's very hardware independent. The only what you need is a Java runtime, and then you can run OSGi. This is kind of the architecture, or an architecture model for OSGi. You have the operating system and the hardware, obviously, and sitting on top of that, what OSGi refers to as the execution environment. So that's basically your Java VM and libraries. And then a module system, so a way to modularize your code, have code declare that it's the other things that it's dependent on, be able to hide the implementation of modules so that you only expose the pieces that you want to be public, that you're contracting not to change. Then you have a lifecycle model, so how do you install, uninstall, stop, start, etc. And then finally a services model that allows the dynamic discovery of services on the device. And then application bundles sit on top of all this, and kind of cutting across all of this is a security model that is based on the Java SE security model and extends it slightly to make it give you some dynamic capabilities so that you can manage the security environment, or at least the permission environment for Java code running on the device. It also gives you the ability to deny permissions as well as allow permissions, which can be handy sometimes. I'm just going to talk very briefly about JavaDB. It's a very nice SQL database, and it runs extremely well on embedded hardware. In fact, it's very widely used as by developers who need a good, reliable, cheap and cheerful SQL database. And we've been very, very pleased with the footprint and the performance that we see on embedded devices with it. Some of the benefits of it being a SQL database, it has the full SQL security model. And it's a very, very full dialect of SQL. So it's very familiar to anyone who already uses SQL. So this is part of, how do you create a platform that allows you to say, yeah, you can take your Java and related skills and you can go here and you can go here. So we don't want to have, a really tiny cut down thing that isn't familiar to most Java developers. You can encrypt the database if having encrypted data on the device is important, to make sure that if anyone does access the raw data, they can't actually read it, or at least not very easily. It's very widely used, and it's supported by a number of different IDEs. Jersey is the reference implementation of the JAX-RS specification. JAX-RS is the JSR that deals with both providing and consuming RESTful web services. And essentially it works by you annotate plain old Java objects, POJOs, in order to define the implementation, the interface of your RESTful service. So you use annotations like @post, @get, @consumes to say what MIME types this particular method can consume, and so on. There's also a client API that is part of the JSR, and the whole thing is designed and built to be very modular and extensible, to be extensible as far as your different security mechanisms, as far as the entity support that you're carrying around with you. So this is nice because it means that you can actually cut things down to something really quite tiny, but as and when you need to add new extra stuff, then the extensibility is there. You haven't just got something that can only be tiny.
Well, we can move on to
the
demo maybe.
Okay. Let's move on to a demo, and I think we'll actually cover this stuff pretty much while I'm talking through the demo. So can you just describe what we have here, Jay?
Yeah.
While I switch over here.
Right. So what Noel's going to show. So here we have a Raspberry Pi, and hopefully everyone's seen a Raspberry Pi before. Hopefully you've used one. If you haven't, it's a fairly cheap device, $35. It's fairly easy to procure, so we like it as a development board. But you could pretty much use any ARM-based hardware that can run Java SE. Any ARM Cortex hardware is good. So we have Java Embedded Suite running on this on top of Java SE Embedded, and it's connected via a wireless router over here. And so Noel has NetBeans as an IDE, and he's just going to show how to create an application using the standard Java model and then deploy it onto this Raspberry Pi.
Okay, thanks, Jay. So what I'm using here is NetBeans 7.3, and everything that I'm about to show you also works just as well with Eclipse, by the way. But I'm choosing to demonstrate with NetBeans today. What I've got here, in this case, I've got a relatively local Raspberry Pi device running Java Embedded Suite. But in reality, as long as I have IP connectivity from NetBeans to the Java Embedded Suite device, then the device can be anywhere. And what I'm going to show you is the ability to start to create applications and to dynamically deploy and update those applications to a gateway device running Java Embedded Suite without having to do things like deploy something and then restart the device in order to be able to invoke that. And you'll see that this is all really quite integrated into NetBeans, and there are additional things along these lines that we're working on as well. So what I've got an SSH window here, which is you can't quite see all the screen, can you now? Jay, maybe you want to move the table forward slightly and unzoom the projector. Oh. We're in this mode, then we're not quite seeing the whole. Oh, thank you, sir.
There you go.
Yeah. Okay, so I'm going to continue talking while the AV gets sorted out. So I've got an SSH window. I'm running Java Embedded Suite on the device. And over here, this is a local window running on the Linux that I've got here. And so I can remotely access the Raspberry Pi to, for example, list what bundles we're actually running on the device. And the connection so that's done using a RESTful admin API, and it's done using a connection that is actually using mutual SSL authentication. So the Raspberry Pi knows that is looking only for specific client certificates to be presented in order to authorize access to that admin service. So it's not just hey, anyone that wants to admin my device, please go ahead. So over to NetBeans. All that I had to do to set this up was to go into the Maven settings in here, and I had to add a couple of settings here. The first one simply tells Maven what's the IP address of the device that we want to deal with today. And the second one simply says whereabouts is Java Embedded Suite installed on this device. And that's simply so that it can find the admin client in order to be able to talk to the device. So that's all the setup you need. We are using the Maven integration of NetBeans and Eclipse. So what I'm going to do here is just go ahead and create a new project. So I can go in and create a project from an archetype. And the Java Embedded Suite SDK provides a number of archetypes for producing different kinds of application. So I'm just going to type Jez in here to search for the Jez archetypes that I've got on here. And I'm going to produce a templated RESTful service built using Jersey. And I'll just call it Demo 1 because I'm not very imaginative today. So NetBeans is now using that Maven archetype and we've produced a little a demo project up here. So I can go into the source code and I'll go into so an OSGi bundle has something called a bundle activator that is called come talk to me afterwards. So I will modify this code here to simply set the path where this RESTful service is going to be deployed on the device. And I'm going to leave that for now. So what I'm going to do now is build this project. So that'll happen pretty quickly. And it's just signing the code now so that so this gateway here that I've got here is configured to only accept trusted signed code. So I just, as part of the build process, then the code got signed by my developer certificate. And so what I can do now is just go in and run that project. And if I bring this window, you'll see this window scroll in a moment. Okay, so this is basically okay. So that's basically log output from the Java Embedded Suite running on the Raspberry Pi, and that's simply basically log output saying, yeah, I just got a new bundle deployed to me. So that's now running, and if I go to my web browser, then I can. So this is running on port 8443. I've got the right IP address, and it's deployed under the path Demo 1. So we should now, oops. Okay, I missed out a character, I'm sorry about that. So I'm now getting basically the class name of a resource back. So just to show that we can change stuff and and update stuff in real time here, then I'm going to change the the string that gets returned by the resource here. So this is obviously a very simple resource. It's tagged to respond to a get, an HTTP get, and it's tagged to be able to produce either HTML or plain text, depending on what the HTTP request is asking for. So I'll save that, go over here and rebuild. And then in a moment, when I rerun it, then this will get redeployed. Because I already have this bundle installed on the gateway, then it'll get the bundle will get stopped, updated, and restarted, and then we'll access it again. So we'll run that bundle. We'll see more log activity happen on Jez in a moment. There we go. So it's just restarted the bundle. So if I go back up here and refresh, you'll see that it now says "Hello Java 1" as the string that was returned by that very, very simple RESTful service. So basically what I'm showing you here is just how easy it is to use standard Java tools and standard development tools and standard Java. I mean, this is Java SE, it's JAX-RS, it's web services, servlets, web applications, and there's a lot more to come in terms of where we're taking Java Embedded Suite. And I think that's enough for the demo, Jay.
Yeah.
Okay. So over to you.
Just to wrap up, I mean, if you look at the method over there, the get resource, which just returns a string right now. I mean, you could do anything in there. You could now open a sensor connection, or you could have a sensor connection which is already open as part of an OSGi bundle, and call another OSGi service which is now returning you data from the OSGi service that's gathering data from all these different devices. Or you could just talk to a local database, which is already sitting there with Jez. And you might have a different OSGi service that has been gathering data from the sensors and storing it into the local database. And this REST service, all it'll do is just go in and query the database for the latest results and return the results. So now you can leverage so imagine a scenario where you have an enterprise application, a web application sitting on a data center. It needs to get the latest data from a device. All it has to do is now make a REST connection to the gateway, call the right REST web service, and it'll have the data. Or you could have another OSGi service which is basically leveraging the REST connection and synchronizing data from the gateway to a backend database at a periodic interval. So the possibilities here are endless, but the key thing being that we really simplify how you do things. You leverage your existing knowledge. You can reuse your libraries that you may have developed for XML parsing, for JSON. You could use JSON quite easily. You could use protocol buffers. You could use anything over here that makes your data transmission easy. So we're not trying to, we're trying to make it simple where you can build on top of it without having to learn new things at this point. So I feel that's the biggest benefit that Java Embedded Suite can provide. And the key thing about being able to deploy things and they just run automatically without restarting a device is key. I mean, that's one of the key things what we can bring with OSGi. And the OSGi really simplifies things over here in terms of making devices far more dynamic. I don't have to restart my device just to get an update. And that can make things far more easier, much more streamlined. So can you go back to the slides?
Sure.
All right. So just one quick thing. On top, Jest is basically a platform, and these are the things we already spoke about. A modular extensible middleware stack, that's what Jest provides. Integrated servlet container, integrated database, RESTful web services, a management framework, optimization for embedded hardware, security framework. So one thing we didn't cover a lot, but Noel kind of briefly covered, which is the security part with mutual authentication. And that is an extremely important point, being able to secure things. And Java by itself has a lot of security mechanisms built in. Like you have the bytecode verification, you have a sandbox, you have code signing mechanisms where you basically can sign your applications, and only the applications that are signed with the appropriate certificate will run. And Jest takes all of that and builds it into a framework where you can configure how you want applications to behave. So you can basically go into Jest and say, only run applications that have been signed by a specific certificate. So that's the kind of security that you can bring in. So you can't just install a rogue application onto a gateway and which can just sit around and do just log data. So that's the kind of stuff that we're trying to bring in with Jest. On top of it, with Jest, we have Oracle Event Processing, which requires its own different full session. But basically, Oracle Event Processing brings in complex event processing on top of Jest. So Jest is basically a platform that allows you to bring in more services. Berkeley DB is another one that I spoke about earlier. Oracle Event Processing allows you to do local data filtering, pattern matching, correlation, and window operation, where you can say if an alarm is on for more than 3 minutes, then take an action. So finally, here's what we're doing with Java Embedded Suite. So hopefully we'll have something for you guys soon. Jest 7 today with itself is pretty cool in terms of what you can do. We're really taking that a step forward, bringing in all those features that people have been talking about with simplified application development. Jest 7 today just uses web apps, but then it doesn't have a whole lot of focus on embedded application development. We're just saying, use your enterprise knowledge, put it on an embedded device. But what we're doing with Jest moving forward is really taking the same knowledge but customizing it, making it simpler for embedded application development, remote application deployment management monitoring. With Java IC Embedded 8, Java Flight Recorder will be one of the features that you'll see. And Flight Recorder, if you haven't seen, it's just amazing. It's like a black box on an airplane where you look at an event after something bad has happened. So instead of trying to reproduce it, like going in and putting debug statements and trying to do all kinds of tricks to reproduce an error, you can just go back and look at the logs and it'll tell you exactly what happened. That's the black box functionality that Java Flight Recorder, and that's why it's called Flight Recorder, because it's the same analogy to an airplane. So that's what it does, and in combination with a tool called Mission Control, you can just open up the Flight Recorder logs in Mission Control and it'll give you a complete visual analysis of what went wrong in the JVM. So that's the functionality that we can bring in with Java IC Embedded 8, and that's something you guys should definitely leverage. So modular architecture, and finally web services. I think REST is the way to go moving forward. We have invested enough in the Java world, and we have to bring REST over to embedded devices. I think that's it. Do we have any time left? We have a few minutes left, like a couple of minutes for questions, or we can hang around if you have any more questions as well.
So the event processing you described, is that covered in a particular session?
Event processing,
Why find out more about it?
we definitely can talk to you more about it. We did a lot of sessions for that earlier, but this year we haven't focused much on it because we haven't changed a lot in the product since we spoke about it last year. So that's why we haven't focused much on content this year, but something we definitely can talk about more. We have demos. If you go to the Java Embedded demo grounds, we have demos in the gateway booth, where we're showing a demo where we use event processing. There's a demo with Freescale, again, where we use event processing. So it's in almost all of our embedded demos. It's just that we don't have any sessions this year.
I was going to say, I have one tomorrow, 11:30, says dynamic M2M event processing.
Oh, yeah, you're right. I'm sorry. Yeah, there is one, yes.
Good.
Tomorrow,
That's what I was looking for. Thank you.
It's,
Perfect. Thank you.
CON 7839.
Right, that's Hinkman Wong, right? the speaker.
Was it 11:30 tomorrow?
Yeah.
In this hotel?
Yeah, did you say Walt?
Hinkman Wong.
It says Walt Bowers and OLED.
Oh, yeah, that's right. Okay, good. That's the other one. Oh, well, there are sessions. And we have a session tomorrow in the morning at 8:30 where we'll briefly cover the topic as well.
Thank you very much. Appreciate it.
Yeah.
So is that Oracle proprietary event processing system or is it like Esper?
So yeah, it's Oracle proprietary. It's similar to Esper. We use a language called CQL, which is, I believe, it's far more powerful than Esper, but it's an ANSI standard. CQL stands for Continuous Query Language. Esper is not optimized for embedded, and we've really taken OEP engine and really shrunk it down, and it's been optimized for embedded. Okay.
I have a question about the OSGi framework.
Sure.
Is it like the standard one which we use in Java Enterprise editions, like Apache
Felix, yeah.
Yeah. So
Well,
they have all the,
That's what we're running today. Obviously, there are a number of companies that also, we've got partners that also sell OSGi frameworks that have been specially written for different use cases and so on.
Yeah, because also there was something like Apache ACE to distribute code onto various OSGi bundles which are in the cloud or connected via IP. So do you see a use case of that, connecting Apache ACE to
I think,
distributing code?
well, I think there are a number of challenges in managing all these devices, that come from, the different protocols. The fact that the device that you want to manage may or may not actually be there to talk to at the time when you decide you want to manage it. There are plenty of mobile devices or battery-powered devices that stay off the air as much as possible in order to have, and that's even more important for IoT devices because you need battery life of years, not days or weeks. So there are a lot of challenges in that. You can't just think of this as a, oh good, we have an IP connection to the device, we can talk to it whenever we like, because you may not have an IP connection, and you probably can't just talk to it whenever you like.
I know in a lot of industries, they don't mind, they like to buy your hardware, but the last thing they want to do is then let you put that back on their network so that you can get into it all.
Yes, and one of the things in the conceptual architecture that we showed was an IoT gateway that sits out in the DMZ and basically mediates between the external part of your IoT network and your corporate infrastructure. And that's a very, very important part of an IoT network or an IoT platform. And what we're really trying to do here by bringing this, the IoT platform and the architecture idea, and there was a lot more detail on that in the earlier talk that Jay and I gave today, is not to say this is the Oracle proprietary way of doing things. It's to say if we're going to make a success out of IoT and create the ability to build applications or lots of applications and really be able to support that many billions of devices in just a few years, then we need to create a platform that the industry can converge around. And therefore, so we're putting this architecture out there, not to say we have all the answers already, but to say that this is how this is where we're at in our thinking. We'd like to know what you guys think.
Is there any how-to guide or quick start guide that covers material similar to the demo you gave?
Which with just 7 has, you can download that from Oracle Technology Network, and there's documentation that comes with it. Some of the stuff that Noel showed today is something we still haven't released yet, but we're hoping that we can release that fairly soon. But you can definitely, there are other OSGi frameworks that work very well on embedded, and they have their own SDKs, so the model is fairly similar in those as well. So if you want to try those out. If there are no more questions, then thank you. I really appreciate your time.
Yeah, thank you, everyone.